Right on time. All right, that works. So, correlation coefficient, lines of best fit, linear regression, all the regressions. Here we go. The first part of this booklet is covering correlation coefficient. This is where you read the answer choices. Are they related? Yes or no. Does one cause an effect in the other? Cause and effect, but the algebra version, right? Now, I promise you, these questions are very, very easy. They are very common sense. They are multiple choice. The hardest part about these types of questions, are reading. And you guys are too lazy to read anything. Please read it. Take a few minutes to read them because I promise you the answer is easy. The answer will stand out. Okay? So correlation means they're related, but one does not directly cause an effect on the other. So, for example, let's see. The example that we used when we first learned this was ice cream sales going up, sweater sales going down. Okay? Does buying more ice cream directly affect the sweater sales going down? No, they're related though. Why? Why would ice cream sales go up and sweater sales go down?
Because it's getting hotter.
Because it's getting hotter. It's getting warmer outside. So it's the weather that's actually causing the effect in those, right? Causation is when one directly affects the other. The longer amount of time that you study, the higher your grade is. Are those directly correlated?
Yeah.
Yes, one does cause effect in the other. You study less, you get a lower grade. You study more, you get a higher grade. Unless you're just naturally smart. That's an outlier. Anyway, which one best shows causation? The length of a rectangle affects the width of the rectangle. So if I change the length, do I have to change the width? No. Answer choice E, the amount of time a cell phone is used, the charge of the battery, it affects the charge of its battery. Yes, the more you use your phone, the more it's going to drain, right? You don't use your phone, your battery is good. F, the number of ice cream bars sold affects the number of milkshakes. No, because everybody has their own preference. Just because some people are buying ice cream bars doesn't mean a certain amount of people are going to buy milkshakes, okay? G, correct. They can buy both. The number of soccer balls a team owns affects the number of games the team wins. No, that one is what? Doesn't make sense. More soccer balls do not equal more wins. So the only one that does make sense, the only one that does show a direct cause is which one? The cell phone. The more you use your cell phone, the more it drains the battery. The next one. It's the same type of question, but opposite. Which one does not show causation? In other words, which one does not make sense? When the student population increases, the number of teachers increase?
No.
This is technically true. If you think about it, the STAR test is created in a perfect world setting. In a perfect world, if there are more students, there should be more teachers. Now, whether they do that here or not, that's different. I need y'all to be focused on this booklet because I see some of you guys on the calculator. You need to be focused on this booklet. You will have time to finish your packet. Okay? B, when the amount of sugar in apple juice is reduced, there are fewer calories. Yes, that is true. Less sugar, less calories. So far, true. When there are more workers on a project, the project is completed in less time. Yes, that's true. But that is also why we don't do group projects, because in a perfect world, everybody would put in their part, right? But this isn't a perfect world. When there's more protein in an athlete's diet, he scores or she scores more points?
No.
Not necessarily. It's all about the player, not their diet. The diet helps, but it doesn't directly affect their game. Okay? So, next page. Correlation coefficient. Correlation coefficient. First thing you need to know is correlation coefficient will always, regardless if it says it or not, correlation coefficient is always linear. Okay? It's always linear. I've only ever seen one question on the STAR test that doesn't say the word linear when it's asking about correlation coefficient. And there's one in the packet, so just make sure it's linear. Most important thing, put a star next to step 3. You have to turn on the diagnostics. Where do you find diagnostics?
In mode.
You find it in mode. So go ahead and go check your calculator to see if the diagnostics is turned on, because if it's not, make sure you turn it on. You press mode. Mode is right next to second. Mine is already turned on. You go up, move it to on, press enter. Make sure the black box is flashing on. Then any and every single table that you get on the STAR test, except for one that we actually saw today, you're going to put it into stat edit. Okay? And depending on whether it has the words linear, quadratic, or exponential, you're going to use 4, 5, or 0. This one says what? What option are we going to use? Linear, quadratic, or exponential? Linear. It does say linear, so we're going to use the number 4 instead of 5 or 0. So put that table into your stat edit. For some reason, I always have a handful of students that still don't know which ones are my X's, which ones are the Y's. When your table is laying down or when it's a horizontal table, X's will always be your top, Y's are the bottom. So L1 is your top row, L2 is your bottom row. It's going to take some time, but go ahead and type that in. 70, 21, 34 times 92, 84. And yes, you must type all of the numbers in for this to work correctly. Don't forget, you can text pretty fast, so you better be typing pretty fast as well. Now, when you do that, because our diagnostics is on, we are going to get 2 values. We're going to get r squared, and we are going to get r. Which one of those values do we pay attention to? Always r. Remember, squared means quadratic. That's the easiest way to remember whether you're going to use r or r squared. Squared is quadratic, so you use r. The first thing that you check is whether it's positive or negative, because there are still students that get mixed up. Should it be weak? Should it be strong? Check to see if it's positive or negative. Give yourself a 50-50 chance at getting this question right. Okay. Now, 0.01 or 0.15. Is that close to the number 1 or 0? Close to the number 0, meaning it is weak. Strong is when it is close to the number 1. Or think about it in terms of money, okay? Either $0 or $1. 15 cents is closer to $0 than it is to $1, okay? Questions on that one? If you forget the steps, you have step-by-step instructions right beside it, okay? With pictures and everything. So don't come asking me. Next page, equations of reasonable fit. Lines of best fit. You get a table. Look for the 3 words, linear, quadratic, or exponential. This one has what? This one has linear, so we're going to use what number? Number 4 instead of 5 or 0. So put this into stat edit and go through all the steps. You got it done, Brantley? So as you guys are finishing typing that in, it says, what is the best prediction of the number of clicks on the advertisement if 1,500 people visit? 1,500 people visiting is what type of value, an X or a Y? It is an X value, meaning we go to second graph, find the 1,500. But what is the fastest way to get to the 1500? Second window. Second window, 1500, then you go second graph. So in second window, you type in 1500, then press second graph again, and you get 83.44, which is closest to which one? 83. The next page is an example of quadratic regression. This table tells us what word? Where does it say that?
Right at the very bottom.
At the bottom of the top, right? So you're going to use option 5. Now, there is going to be one in the packet. There was one on the STAR test before that didn't have that word. So you had to rely on the answer choices. What do all of your answer choices have?
X squared.
An x squared. Very good. X squared automatically tells you that it's quadratic. All right, what do you get for A? B?
Negative 3.1.
And C?
0.00.
So C is 0. You should actually get 0, like an actual 0. Anyway, so that gives us what answer? H. Yes, because we picked H in this specific example, I've had people in first and second period say, so we don't use C. The only reason we don't use C in this example is because it would be a +0. They're not going to write +0 on the STAR test. Got it? Last page. What option are we going to use on this one?
0.
Because it says what?
Exponential.
It says exponential, so we use the number 0 instead of 4 and 5. This is a shorter table, so good for us. Let me make sure my audio is still recording. Because and I am going to do a couple of the ones from the packet with you, just in case you guys didn't get it correctly. So for A, you should get 0.02, and for B, 2. If I create my equation, if it asks me for an equation, what would the equation be? This is exponential, bless you. What would the equation be? (0.02) parentheses
2 parentheses
to the power of x. But it's actually asking us for something a bit more.
10.
It says predict the length after what?
10 years.
10 years. So if you go to the 10, that is your x value. If you go to the 10, what do you get?
20.48.
20.48. Now, this specific griddable on this packet has that decimal. The algebra test is not going to have the decimal for you. You can actually write this number down anywhere in the boxes. Okay? All right. Now, I wanted to go over lines of best fit with you guys. So flip over to number 8 in the packet. It should still be in the box. So with lines of best fit, they're called lines of best fit for a reason. You want it to best fit all of the points, meaning it has to be a good average of all of the points on the graph. In order to do that, you want to put it in the middle of all the points. Now, this one, it's very hard to get the middle of all the points because you have a couple of points that just kind of stand out. These 2 points are called your outliers. So my line of best fit for this one is actually going to go in the middle of the points. You are going to have a feature on the STAR test that's going to let you draw a straight line. But notice how the line that I drew has all of the points very, very close to it, except for those 2 on the outside. Those are called my outliers. Now from there, it says, predict the number of baseballs that we are going to use if we have 275 pitches what? Thrown. So pitches thrown, 275 is in between 270 and 280. So if I go straight up, I touch the line and then I go across, and that is what? 100. Now, there's only one other line that's actually pretty difficult to draw, or it just depends on where you put it, because it has a lot of outliers. It has a lot of outliers more in this area right here. So because there's a lot of outliers here, the middle of these points is going to be this one. So that's why I connected this one to that one. And then I found my answer from there. Okay, so make sure your line of best fit on number 9 matches mine. Other than that, if you need something to help you draw a straight line, there's a bucket of rulers over here on the side. Okay? All right. Go ahead and finish up that packet. If you're confident in your answers, the ones that you've already picked, then turn it back in.